right, well, good morning, everyone, and welcome back to another exciting day in mathematics. Warm-up 116 is on the screen, and you're going to notice that 1, we know how to do. I'm sorry, not 1. 2, we know how to do. 3, we know how to do. 4, we know how to do. And I'm introducing something new with number 1. Give it a quick stab at it, see how you do with that. But yeah, because we're moving on. We're almost getting there to the next function. So let's see how you do with that. Give you some time. Go. All right, here we go. For the sake of time, I'm going to go over the first one. Here it goes. So it says, use -1, 0, 1 to evaluate the functions. Okay. I'm going to start with this one. Look up to the screen. This first one, and I'm going to evaluate according to these values for x. So I'm going to rewrite that as f of, my first value is -1, equals, pay attention please, 2 to the x minus 2. But instead of x, I'm substituting what value? -1. So it's -1 minus 2. So f of -1 equals 2 to the -3rd power. However, remind your neighbor, can we have negative exponents? No, Mr. Q. So f of -1 is 1 over 2 to the 3rd power. So what is 2 to the 3rd power, Jacob squared? Very good. 8. Yes. 1/8. Stay focused, people. Next value. We got f of 0. F of 0 equals 2 to the 0 minus 2. F of 0 is 2 to the -2. Can we have negative exponents? No. So f of 0 equals 1 over 2 to the 2nd, which is what, Jacob squared? 4. Let's go. And then we go to +1. So this is f of 1 equals 2 to the 1 minus 2. F of 1 is 2 to the -1. So f of 1 is 1 over +2. Not bad, yes? All right. So I helped you with that. Do f of x equals 10 to the x minus 1. Same process. I'll give you a head start. All right, let's see. Walk us through writing. F of -1, what do I write? 10 to the -2, which is f of -1 equals to 1 over 10 to the 2nd, which becomes 1 over 100. That is correct. Hands, have you got that? All right. Next, pass someone. Right. Who? Anthony who? Anthony E. F of 0 equals 10 to the -1. F of 0 equals 1 over 10 to the 1 or 1 over 10. That is correct. Let's go. Anthony E, pass someone. Anthony G, f of 1 equals 10 to the what? 0, which is 1. That is correct. Hands, if you got that by yourself. Okay, good. So that was number 1. Numbers 2, 3, and 4 you should be able to do by yourself. However, let me go over number 3 and 4 just to make sure we got those. Look at 3A. Tell your neighbor what this becomes. What does that become? Courtney Jean. Yeah, 1 over A to the first. About 1B, Denelli. 9 to the 0 power is 1. That is correct. Mr. Q, how about this one? Oh, this distribute the exponent. That becomes 1 to the negative 2 and 7 to the negative 2. But we can't have negative, so what do, Jacob? What do we do if we have negative exponents? Yeah, he said send 1 to the denominator, 1 with a positive 2, and the other one to the numerator, 7 to the positive 2. So therefore, what is 7 to the positive 2? 49. 1 to the second, 1. So this is 49. Last but not least, x to the third times x to the fifth became x to the 3 plus 5. So, what was this? 4 to the x plus 2 plus negative 2. What was it before it became like that? Tell your neighbor, and then Brandon's going to enlighten us. What was it before it came like that? All right, Brandon, Felix. To the negative 2. Yes, that is correct. However, can we have a negative exponent, everyone? No, so we leave 4 to the x power over 4 to the positive 2. And if we simplify a little further, this is 4 to the x over 4 to the second is 16. Woo-wee. We good, yeah? Martin, how you doing over there? Okay, good. All right, so with that said, copy the agenda. Warm-up number 116, rational functions. Tonight's home play numbers 13 through 18 only. Found on, I attached some pages from a resource for this section. This should be on the code that I'm going to give you right now with Nearpod. All right, we good? All right, so with that said, your code for your home play, write this down, 4VQWN. 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 All right? So your home play you're going to find in there. Make sure you have that code. Those of you following us on YouTube, once again, go to that code. That should give you access to today's presentation, including the home plate. All right. So, get a Cornell note. Also, I'm going to give you guys some time to set up 6 coordinate planes, once again, from negative 10 to 10. 2 per page. Give you some time. Go. All right. So, here we go. Our objective for today, I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. So last week we spent plenty of time of graphing rational functions. I call those basic rational functions. And put away your mobile devices. My goodness. Bah. All right. So, today, we're moving on. So just to make sure we understand where we've been, look up to the screen. We know what rational functions are. Is that correct? All right, tell your neighbor the definition without looking at your notes. What are rational functions? What are rational functions? Looks like Danny's got it. Jay's got it. Very good, Jay. Brandon Doherty's got it. Very good, Brandon Doherty. Maya's got it. All right, see you, Maya. All right. So, for the sake of time, look up to the screen. Rational functions are what? Equations that contain what? One or more rational expression, also known as the fraction. All right. Next. I gave you guys some steps. So writing utensils down, look up to the screen or you're going to miss it. Last week, these were the steps. This week, these are the steps. Last week, this week. Last week, this week. Last week, this week. So what's the only thing that changed, Jay? The first step, woo, let's go, which entails what? Your favorite, long division. Let's go. However, that's just for graphing. Today we're going to be writing equations from a graph. Look up, and these are the steps. You're like, what? Yes. I'm going to leave them up there. You're going to have them as we go to those problems at the end. But that's the process we're going to follow. So right now we're going to focus on graphing. Now, reminder, we now are in this general rule for rationals. And we know what they are because they include now asymptotes. Last week we covered vertical and horizontal. We still are on those. Right? We know what they are and how to get them. From there, we went to graph B. However, now we are here. Copy that, please. Example 1. And it reads, rewrite the function and graph identifying the domain and range. G of x equals 3x minus 4 over x minus 1. Copy that. G of x equals 3x minus 4 over x minus 1. So for today, and from this point forward, I'm going to simplify the graphing portion just for the sake, because these require a little bit more work. So, here it goes. Writing utensils down, look up to the screen. You'll copy right after. So as you're copying that, I'm just going to move this over to the left a little bit to make some space on this side. And then I'm going to bring this one over here. All right, next, look up to the screen, please. Writing utensils down, you'll finish copying a little bit. Look up to the screen. Very important again. Question. What is 3 plus 2? What is 2 plus 3? So does the order matter? No. Therefore, same idea with this. This plus that is the same as that plus that. Is that correct? So I'm going to be able to switch this one to the end. Bring this one to the end. So I'm going to do -1 over x minus 1. And then I bring down the 3 at the end, and it's a positive 3, right? Positive 3. Hold on before you copy. I'm almost there. What needs to be on the numerator by itself? The 1, is that correct? So what do I do with that negative? Well, Mr. Q, you can send that to the front. So I end up with negative numerator 1 over x minus 1 plus 3, and this is my new function. Copy that, please. Woo-wee! Let's go! Mr. Q, give us a pop party tomorrow. Well, we got this. Woo! So as you're copying that down, here goes the process one more time. I was given g of x equals 3x minus 4 over x minus 1. And your brain said, Mr. Q, the numerator is not a 1. What do? Use long division. Now, there's going to be some guys that you can actually simplify by factoring and then simplifying from there. But for right now, we're doing long division. Here it is. We did long division, yada, yada, yada. We wrote our answer. Here it is, 3 plus the remainder over the divisor. But we still said it doesn't look like what we did last week, so we sent the constant to the end over here, this to the front, but we still needed to leave the 1 by itself, so we sent the negative to the front of the fraction, and this is our final equation. Do we know how to graph from there? Yes, Mr. Q. All right, let's continue from there together. Everybody, let's find our VA and our HA. So, turn to your neighbor, let them know what the VA is and what the HA is. VA and HA. And then Brandon's going to enlighten us. All right, VA, Brandon, Darty. 1. How about our HA? 3, that is correct. All right, so let's plot those. 1 is here. Dotted line down that's our asymptote. And y equals 3, which is right here. So far so good, yes? All right, so now next, before we move on, look up. To make the graphing portion a lot faster tonight with the home plate, I'm only going to ask you to do 2 values in our table. So here it goes. Look up. I'm going to write x, g of x. What are those values? So I'm only going to need 1 value from the left of the asymptote and 1 from the right. So tell your neighbor which values of x am I going to use. Then we'll have Martin enlighten us. Which values are we going to use for x, Martin? 0 and what? 0 and 2. And how did he get that? Well, here's our asymptote. And we said we're only going to need 1 value from the left and 1 value from the right for tonight's home plate. For those of you that are not following along, then you're probably going to be doing more numbers than that. All right, so let's graph this. Let's get some values in here. Look up. I'm going to write 1 over parentheses minus 1 plus 3. I'm going to write it twice for each of those values. Oh, this is 1, sorry. Plus 3. All right, my first value is 0. All right, so here it goes. Help me out with this, Brandon, Darty. Let me zoom in. Here it goes. What is 0 minus 1? And 1 divided by negative 1? Negative 1 plus 3. 2. That is correct. Ooh, Brandon, Darty, let's go. You must have had breakfast like a tiger. They're great. All right, hold on. Let me put a 1 here. Next value is 2. All right, Brandon, Darty, 2 minus 1. 2 minus 1. Divided by 1, plus 3. So far so good, yes? All right, so let me zoom out. We got our values there. So watch. Look up to the screen. 0, 2. 0, 2. Look up. We know that one is right here. The other one is 2, 4, 2, 4. I would be done. Look up to the screen, except for what? Tell your neighbor what did we skip? Circle it, right, hold. We needed to hold that till the end. And tell your neighbor, what do we do at the end with that? What do we do at the end with that? And then Martin's going to enlighten us. Martin, go. You flip it. All right, so let me zoom in. So if we flip these according to the asymptote, this one is one step away downward, so I'm going to go upward. This one is one step away from the asymptote upward, so I'm going to go downward. And there you go. All right, and that's the process. From 1 to 5, how comfortable are you with today's functions? Yeah, 4 5s, 4 5s, yes. Why? Because we did all the other leg work already last week. All we need to do is rewrite our function. So, let's go to the next coordinate plane. Copy this one. Example 1Q. And write g of x equals 4x minus 7 over negative 2x plus 4. So, tell your neighbor the very first step that you're going to do. Very first step. Very first step, Danny. Yeah, set up the long division. All right. So, here's my long division. What goes inside, Danny? And outside we got negative 2x plus 4. All right, pass someone so they can help me do the long division. Anthony D. What number times negative 2 gives me positive 4x? Negative 2. So, negative 2 times negative 2 is positive 4x. Negative 2 times 4, that's negative 8. Subtract. That means I'm going to distribute this one here and here. So, this cancels. And we're left with positive 1 as a remainder. How do I write that to get started? Pass someone, Anthony D. Who? Bree, tell me what to write. The answer. What is the answer to this division? Plus 1 over negative 2x plus 4. Hands, if you agree up to right there? That is correct. Pass someone, Bree, so they can continue transforming that. Who? Claire? What do I write? Claire. Negative 2 to the back, so tell me what you write. Minus 2, and all that equal to g of x. So far so good, yes? How we doing? All right. So, what is our VA and our HA? So I'm going to give you the HA. HA is here, so that's -2. So it's right here. Oh, sorry. HA -2 down here, sorry. Then I'm going to have Jacob give us the VA. Jacob, go. X equals? You said 2? Yep. +2? Yes, that is correct. You said that is equal to 0. -4 minus 4. -2x equals -4. Divide by -2. X equals 2. That is correct, man. Jacob, let's go. Then there it is. All right. Next, we need a table. X, G of X, and we're going to need 2 values. Turn to your neighbor, let them know what X values we're going to use for our table. All right, looks like Laura's got it. Very good, Laura. Well, let's go with Mitos. What values? What is it? 1 and 3. That is correct. How did Mito see that? Well, here's my asymptote. 1 from the left, 1 from the right. There it is. All right. So let's write this. We got 1 over. Give me a second. Where was I? Oh, yeah. 1 over -2 parentheses plus 4. So let's see. Brandon Daugherty, help me out. -2 times 1. -2. Oh, I forgot the -2. Hold on. And the -2. All right. -2. -2 plus 4. 2. So this is 1/2 minus 2. That gives us -1.5. That is correct. Do the second portion for the 3. All right. Mandardi, 3 times -2. -6 plus 4. -2. So this is -1/2 minus 2, and that is -2.5. So let's plot those. 1 and -1.5. 1, -1.5. And 3, -2.5. Look up, guys. So notice where this point is at. Let me zoom in. Look up. Notices that this one now is above the asymptote. It should have been down here. Is that correct? So since it's above, remember, whenever you do your curve, make sure your curve is away from both asymptotes. So curve it away from both asymptotes. Same thing over here. Curve it away from both asymptotes. Okay? Now, quick analysis. Look up. Let me show you the equation. Who notices that this one has a negative in the denominator? Yes? It's the same as if I was to move that to the front of the function, which means at the end we would do what if we wouldn't have used the negative? Yeah, flip it, right? So since we didn't do the hold, but we included in the computation, we did the flip automatically. Okay? So from 1 to 5, how comfortable are you with that? 5 fours, 5 fours. We got this, yes? And so on and so forth. So I think we got it. Look at this one. Look up. Do you know what to do with that? Yes? Yes? How about this one? Yes. All right, let's get to the funner ones. Copy this one. Example 2, it reads, write the equation of the function given the graph. Use the form g of x equals a parentheses 1 over x minus h plus k. And then copy the graph exactly how it is on your graph paper. Now notice here they grayed out, look up, they grayed out the asymptotes, but I'm going to use my color, my technology, awesome technology tool to highlight those asymptotes so you can show them on your paper. Let's see. The red one is right there, and the blue one is right there. So then plot the point here, curve it, plot the point there, curve it, then I'll wait for you. So, writing utensils down, look up to the screen, please. Here goes the process. Basically, in order to write an equation, we work our way backwards. Y'all ready? Here it goes. Step 1, we need to write the form. Did they give us the form? Yes, Mr. Q. Step 1 is done because they told us to write that down. Step 2, identify the VA and the HA. VA and HA. So let's do that part together. Look at your graph. Tell your neighbor what the VA is and what is the HA. All right? Good conversation. Emily P., what's our VA according to that graph? Here's a blue one. Our VA is -2. That is correct. Write that in there, -2. What is our HA, Emily P.? 1. Yes, right there. 1. Okay, so we got that. Step 3, look up to the screen. Pick 1 point. So, how many points did they give us? 2. 1 up here and 1 down here. So let's ask Maya. Maya, which one shall we use? The top one or the bottom one? Top one. Okay, Maya says the top one. Look up. So label this one in green and label the values. This is x and this is g of x. Lastly, we're going to substitute all these values into our form. So here we go. Look up. What is g of x? 5. Equals. We don't know what a is, so I'm going to write a. The 1. The minus. Do we know what h is? Or the VA? It was what? -2. Do we know what x is? Yes, x is -3, which is over here. And do we know what k is? Or our y equals? Yes, that's +1. So, let's simplify and solve. 5 equals a. 1 over negative times the negative is a positive. Okay, I am going to hold you till we finish. Some of you started putting away your stuff. Here we go. What is -3 plus 2? -1. So what is -1 over 1? What is it? -1. Okay. So this is a times -1 plus 1 equals 5. Subtract 1. Subtract 1. This is 4 equals a times negative 1 is negative a. And how do we cancel this negative? Divide by negative 1, so this is negative 4 equals a. Okay, I'll wait. So, how do we do now? What do we do now to write our form, but now with all the values that we need? Well, we bring this down, and I start g of x equals a. What is a? Negative 4, parentheses, 1 over x. What was h? Negative 2. So what is negative 2 times a negative? Positive 2. And at the end, plus 1. And that's how you write your equation. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Bye, guys.